Hi, this is a discussion and review about this simple test. A relation called patient lab that contains patient information and insurance information and the lab test information. And a patient could have multiple tests in one day, such as like a Joe Wei had three tests on May 5th. And you can see a same test for Joe Wei, which is WBC, can be performed by two different dates. So a patient can have a same test for different dates, and also a patient can have different tests in one day. So this is a situation where the table stores this kind of information, and there are patient ID, names, instruction code, instruction name for the instruction code, date of birth, lab test ID and lab test name for the lab test ID, and lab result and lab test date. Now this table is not normalized, so by default a table without normalization could possibly have insertion anomaly, deletion anomaly, and modification anomaly. So I want to give you an example that is an insertion anomaly. The insertion anomaly means that you are inserting a record that make the database inconsistent. So let me type up the insertion anomaly for instance, if one wants to insert a new record for P001, but however enter with Joe Wei instead of Joseph Wei instead of Joe Wei. In that case, that same patient ID P001, some are Joe Wei, some are Joseph Wei. So it becomes inconsistent. The table becomes inconsistent. This is called insertion anomaly. Means you insert a new record, but the database becomes inconsistent. The other situation is called deletion anomaly. Means you want to delete a record, but you lose the information. Let me give you an example. If one wants to delete P002, which means these two records, actually one wants to delete P002, so the whole record will get deleted. However, the only place that has information about AR004 is only combining with P002. So therefore, if you delete P002, then of course that PL004 information also get deleted. So that is called deletion anomaly. When you delete information, then you are also delete the information that is not supposed to be deleted. But LL2, you still have another record, that is, this record contains LL2, L002. So that is called deletion anomaly. Now let's work on a modification anomaly. So this is the example I want to show you. So if someone wants to change the Joe Wei to be Joseph Wei, then all the records for P001 have to be changed. If any one of them are not changed, then the database becomes inconsistent because some are Joe Wei, some are Joseph Wei. So this is called update anomaly for deletion, for insertion, deletion, and modification. So this is the example, and let me know if you have any question. So now we are going to, for question number 2, identify functional dependencies, and then I already, in the final, I will give you the same way. The primary key will be given, and in our case, the primary key will be patient ID, lab test ID, and lab test name, and lab test name. The reason is, if you given a patient ID, and then the lab test ID plus the lab test date, then you can determine all the rest of the values for in one record. If you just give me patient ID, as you can see from the example, you have so many different records. But if you just give me patient ID and lab test ID, but the question is, a patient could have same lab tests in different dates for this case. So just give me the given patient ID P001 and lab test ID L001. You have two possibilities, right? Could be, yes, you have the same test, but maybe different dates, different result. So you need to have, if you want to uniquely identify the list of the values in one record, you need the lab test date. So therefore, I choose patient ID, lab test ID, and lab test date as the primary key. Now, don't worry, in the final exam, you will be given what is the primary key, what attribute forms the primary key, So I give you patient ID, lab test ID, and lab test date, 3 fields as the primary key, because only you have these 3 values, you can uniquely identify one tuple. Alright, so that is a question. I'm sorry, that is a this is like a non-information report for your exam. Now the question is, we want to find out what are the functional dependencies. Now what we are looking for is full functional dependencies, not just functional dependencies, which means here is talking about full functional dependencies. Now the full functional dependencies, we know that patient ID plus lab test ID and lab test date, we can only fully functionally determine the lab test result, because the name actually fully functionally depends on the patient ID. Insurance code depends on the patient ID. You don't need to have the lab test ID. Insurance name, you just need the patient ID. Date of birth, of course, just need the patient ID. But lab test name, I just need the lab test ID. I don't need to have the patient ID. Lab test result, yes, I need to have 3 attributes to get the lab test result. So this is the functional dependencies that patient ID plus lab test ID plus lab test date, then you can uniquely identify the result. I just explained you need 3 because patient ID, you have multiple tests in one day, or same test you can have different date. So if you just give me patient ID and lab test ID, I can have multiple results because I have the same test with different dates. So if you give me the patient ID and lab test ID plus the lab test date, I know everything. Yes, so this is the primary key, but only one attribute is fully functionally dependent on the primary key. I just explained to you the name, I need patient ID. Insurance code, I only need the patient ID. Insurance name, I just need, because given my name, I know what is the insurance. And lab test name, just need the lab test ID, I don't need the patient ID. And lab test results, I need 3 attributes values. Okay, let's look at the other functional dependencies. So this is the primary key, and this is the only one field fully functionally depend on the primary key. So let's see other fields: name, insurance code, insurance name, date of birth, and lab test name. They are attributes, but they are not fully functionally depend on the primary key, which is these 3. So those fields are called have partial dependencies onto the primary key. So let me just draw it out. All right, we already identify lab results fully functionally dependent on the primary key, which is patient ID plus lab test ID plus lab test date. Now, all other attributes, name, insurance code, insurance name, date of birth, and lab test name, they are partially depend on the primary key. We call this as partial dependencies. So FD2 means that patient ID can determine the name, insurance code, insurance name. So the lab test ID can determine the lab test name. This is called functional dependency 3. And because it partially depends on the original primary key, therefore we call this as partial dependencies. So this partial dependencies is talking about the partial dependencies on the primary key for these 4 attributes, depend on the patient ID, which is the partial primary key. and that type's name partially depend on the primary key. That type's ID, so we call this is a partial dependencies. So try to understand that this is partial dependencies is because partial dependencies on the primary key. And then according to the slides we have, so according to the slides, to make the first normal form to be the second normal form, once we identify the primary key, and then we also identify the functional dependencies. If you can find the partial dependencies, and then you have to remove those attributes from the original table and form a new relation along with the copy of the determinant. Now we also can find another functional dependencies that the insurance code can determine the insurance name. Obviously this is the common sense. So we make it as we note it as a transitive dependency because patient ID can determine the insurance code, and insurance code determine the insurance name. So A determine B, and B determine C. And insurance name doesn't depend on the patient ID, and also insurance code doesn't determine the patient ID. Insurance name doesn't determine the patient ID. Insurance code doesn't determine the patient ID. So this is called transitive dependencies. Let's continue for the normalization process. So it is already in first normal form. So the original table is already in first normal form, and the second normal form is to find any partial dependencies and process it. So there are two partial dependencies, which is dependent functional dependence 2 and functional dependence 3. So alright, so according to second normal form, when we find the partial dependencies at P2 and at P3, we are going to remove the name, insurance code, insurance name, and date of birth out of the original table with its determinant, which is patient ID, and form a new table. So we call this table is a patient table. And then, so these four fields will be removed. Also, according to functional dependency 3, which is also a partial dependencies on the primary key. So we remove lab test name from the original table with its lab test ID to form another relation, which is lab test. So we create a new table lab test, and then this is the primary key lab test ID, and then original patient lab. After you remove all these 5 attributes, there are only 3 attributes. And 1 attribute left with its determinant, which is the original primary key. So the table becomes these 3 tables. We got this table. We have new table, lab test table. We also have a patient lab table, which is primary key. So this is after first, second normal form. There are 3 tables. It becomes original table becomes 3 tables. So let's go to the third normal form. The third normal form means a relation in first normal form and second normal form, and there is no non-primary key attribute. It has the transitive dependent on the primary key. So if after you identify primary key, identify functional dependencies, if transitive dependencies exist on the primary key, then we remove them by placing them in a new relation. So in the third normal form, we found there is one transitive dependencies, which is D4. So we will remove the insurance name from the patient table and form a new table. So that is an insurance table with what insurance code as the primary key and insurance name.